Hello, I'm Oliver Cronk, ScotLogic's Technology Director. I lead on research and development, which includes our work on applied AI and also our sustainable technology practice. And this is going to be a talk about balancing AI innovation with sustainability. The discourse around AI and sustainability often positions them as competing forces, innovation pushing us forward while sustainability acts as a bit of a brake. We propose, when we've talked about this topic before, we propose that actually there's a different perspective on this, that innovation and sustainability actually strengthen each other. And as my colleague Suzanne eloquently said this when we gave this talk at a UK government department recently, innovation without sustainability is short-lived. Sustainability without innovation is stagnation. So this talk is very much going to be a journey. There'll be some ups and downs, but please do bear with me. I want to give you a view of the journey that's happening with AI at the moment, with some specific references to the UK, as we are a UK-based technology consultancy that does a lot of work in the applied AI space. And also we're a B corporation, so we really care about our impact and the impact of our clients' use of technology. I should also say that what I'm about to talk about increasingly isn't an outlier perspective. Despite a lot of the talk in the tech sector, we've done a lot of review of the literature. We've done an extensive literature review of industry and academic material relating to this topic. And I'm pleased to see more and more organizations coming out and saying, that they're waking up to the realities that I'm going to be talking about in a minute. In particular, I want to draw attention to a TED talk that's come out very recently by Dr. Sasha Lucioni from Hugging Face that's well worth a watch in support of this conversation I'm about to have now. So in terms of the structure of this, firstly, I'm going to talk about how we look at measuring the impacts of technology. Second, there's fantastic potential from AI, but it's a specialist area. And the reality is there's a lot going on under the hood, out of sight, that many aren't seeing. And so we'll dig into some of the realities of the AI story. And then finally, we'll look at some of how the UK can design and deliver approaches to AI that are more human-centered, scalable, and sustainable. Before we get on to that, I wanted to talk about the holistic view of sustainability that we have. So at ScotLogic, we don't just see sustainability as just about green or carbon emissions. It's far more interconnected and complex than that. And actually, I say it's complex. Some of this can actually really help simplify things within large organizations. There's some great alignment here that's possible, where you look for a win-win-win approach, where you look for cost reduction approaches that are also reducing the impact. So for example, this are reducing the hardware that you need, reduces not only the environmental footprint, but reduces costs. And there's also security and risk improvements here as well. Like often simplifying your technology estate or simplifying things vastly reduces the attack surface or the risk. Getting on top of legacy systems and modernizing, means that skills availability and support can also be addressed at the same time. So there's often a win-win-win story in here, and it's not about this tension between sustainability being a cost. There's actually a lot of good alignment here. Next, I want to talk about sustainable development goals. So the sustainable development goals are often used by many organizations. Many are committed to them. But how many companies are really thinking about these and factoring these into their technology projects? Technology can be an amazing contributor to these goals, but the reality is technology also has an impact. And I'm going to be talking more about how we reduce the negative impacts of technology. So let's talk about what some of those impacts look like. And here we're really looking at the environmental impacts. There's also social impacts, but that's really a whole other talk. In terms of the environmental impacts, the one that gets talked about an awful lot is energy consumption. The electricity that's used by our technology is significant, and it's often pitched as a positive story that the technology industry is using renewables, or it's offsetting, or it's using low carbon sources of energy. The reality is somewhat more nuanced, and we'll get into that in a moment. But the other thing to consider is it's not the whole picture when it comes to the environmental impacts of technology. Yes, it's a significant portion of the environmental impact, but actually we need to look at the full life cycle impacts of technology, which include the supply chain, the mining, the factories that are used to produce the hardware that we're using that powers the services. We also need to think about what happens at end of life. The disposal of e-waste is a significant and growing problem. And increasingly the water and land usage that's required for our increasing data center footprint across the world. Data centers are starting to cover significant sort of parts of the world, and also they're often in water-stressed areas, and that creates knock-on impacts to people and the life, nature that's in those areas. So to say this is, I'm really only scratching the surface here, but there are a bunch of environmental impacts that we're often overlooking. We're not seeing them because they're not front and center for us, particularly those of us that live in the global north. A lot of the impacts happen in the global south, and so we're somewhat obliviously, ignorant to the real impacts of our technology usage. So what we wanted to do was, once we've identified these impacts, how do we map and measure and think about the scale of them? So what we did was we created something called the Technology Carbon Standard at Scott Logic. And I'm pleased to say this is now referenced by the Gov UK GDS Service Manual. And it's also used a lot in our work with the Government Digital Sustainability Alliance. And essentially what it is it's a practical tool that helps organizations understand and influence their technology-related sustainability challenges in terms of, what decisions are they going to make in the future, and think about policy and governance. The other thing is we found it a really useful tool to bring sustainability stakeholders together with technology stakeholders, because often sustainability lives in its own specialist world with its own language, and technology is, of course, a technical field. And what we tried to do here, and it's generally worked pretty well, is bringing together those two worlds, because what we have here is a merging of life cycle analysis, or LCA, the greenhouse gas protocol scopes, and then the areas of the technology landscape that technologists would recognize. So what this covers is upstream, operational, and downstream. And I'll just spend a little bit of time walking through some of those parts. So let's start with upstream. Upstream actually is really significant. In our work with clients, they've been really surprised to see that it's not always electricity consumption that's the significant impact area. It's actually the procurement of hardware because of those hidden impacts I was talking about earlier. Often 50 to 60% of carbon emissions even can be related to the procurement and purchasing of hardware, because those devices have significant requirements for power and sourcing materials. That there's a surprising amount of impact there. The great news is that procurement policy can reduce that impact, looking at extending lifespans of devices, for example, from say 3 years to 4 or even 5 years or more, can significantly reduce the impact of upstream emissions for hardware. The next one I want to talk about is downstream, and I'll come back to operational in a minute. And downstream emissions is interesting because, governments and organizational efficiency of the digital services they build is where impact can really be driven here. What is this area? Essentially, what it is, the digital products and services that we build get in the hands of customers, they use them, and that use has impacts. And so therefore, how we design digital services has real significant impacts, particularly if you have large scale user bases. If you have hundreds of thousands or millions of users consuming your digital services, whether that's a website, an app, or other service, that has a cumulative impact. And so if we build more efficient, design more efficient services here, we're reducing the impact that users have on the use of our service. This also ties back to the upstream emissions piece as well. If you build a service that requires a customer or a user to go and upgrade their device, well, then you've just contributed even further to the fact that emissions are created when people buy new devices. So there is an interesting relationship here between downstream emissions and upstream emissions relating to hardware purchasing as well. And then I said I wanted to talk about operational emissions. As I said earlier, operational emissions, particularly the electricity usage, is significant, and it tends to be where the technology industry focuses attention. These operational emissions break down into two areas at a high level. You have direct and indirect. Direct is where there's the direct running costs from powering the devices or the servers and the hardware that you have with electricity. So where you pay the electricity bill or your organization pays the electricity bill, there's a direct sort of impact to the carbon that's associated with that electricity. And then indirect is where you may have a managed service or a cloud service or something where a third party is running the technology on your behalf. So you're not directly paying for the electricity, but ultimately, as part of the service that you're consuming, some of that cost that you're paying will go towards paying for the electricity that powers the service that you're running. So I wanted to land on operational at the end because I wanted to talk about the picture that we get when it comes to AI. And with AI, there's often this picture that it's very efficient, it's very green, and there's lots of comparisons being made to railways. So I wanted to use this sort of analogy, this railway analogy. So much like the railway investments, the story around AI is often one of inevitability, that a sense that it's all under control, it's on rails, the technology will sort itself out, and we just need to get on board this train. That optimism isn't necessarily wrong. It's the reflection of the excitement and genuine breakthroughs we've seen in the last couple of years, but it's incomplete, right? Beneath that headline story, there's a much more complex reality about how AI actually works, particularly generative AI, and what it costs to keep that running. So, many of the pictures we're shown are of sort of seamless, limitless progress, systems learning by themselves, scaling effortlessly. But in practice, the infrastructure beyond this behind this progress, sorry, is actually very energy intensive, material heavy, and still maturing, changing, and evolving rapidly. And at times, this technology can feel magical, or almost magical. But the reality is it isn't, and the physics and economics underneath this technology are very real. I guess my point is here, it's not that we've been misled, it's just that we're at risk of just looking at one dimension, one side of the story. And our job as technologists is really to look at the full picture, not just the capabilities, but also the dependencies and the sustainability footprint that comes with them. And once you see this, it becomes clear that it's not a reason to slow down, it's a reason to innovate smarter. So what I want to do is show you what I think is an analogy, a train analogy that perhaps is more reflective of the realities. The current AI journey isn't quite as frictionless as it seems, and we need to be careful that we're not misled into thinking that we have a silver bullet train here, like a magical solution that can just achieve anything as long as we give it enough power and resources to get there. Achieving general intelligence that can replace people if only we power it, say, with enough energy and enough data center infrastructure and data. Much of this promised progress is driven by sheer horsepower, by just throwing more and more power and energy at things. And in some cases, we're literally, or the tech industry, sorry, is literally powering data centers by placing local gas turbines right next to them because the electricity grid just simply can't keep up. This tells us really that the system isn't balanced. We also have the issue of electronic waste. The current AI race is driving a huge amount of consumption of GPUs, the specialist hardware that's used for training and running AI models. And these are rapidly being replaced, and it's generating quite a lot of e-waste, and certainly will in the years to come. So this isn't an argument against progress. It's just a reminder that scaling without efficiency hits both environmental and financial limits. All this costs a significant amount of money: the power, the infrastructure, the hardware. And it's something we really need to sort of do a bit of a reality check on. I guess the point also isn't that the train is off the tracks. Sorry, it's that we can lay much better ones and avoid a significant correction. That correction threatens to undermine the productivity that we're trying to gain and the cost savings. Because ultimately, if this technology continues to be incredibly expensive, then it's just not going to achieve the return on investment that we're all hoping for. So I think we've hit a point where performance gains from purely scaling from brute forcing are flattening. We're hitting limits, and the costs, financial, carbon, and opportunity are rising. And that's our cue really to innovate differently through design, efficiency, and smarter deployment. I also want to talk about trust because if we stay on this track here, there's also another concern to think about, which is information quality, not just the energy usage. So the bridge has become synthetic in nature because what's happening in reality is we're seeing generative AI train on its own content. So it's creating an awful lot of content now. And what's been shown when AI models train on their own content is they start to collapse. There's something that researchers call model collapse, where they learn from their own echoes. They gradually lose connection with verified human knowledge. So it's a reminder here really that AI depends on the integrity of the information landscape that sits underneath it. We can't brute force this forever because ultimately we're potentially degrading the information that this thing is operating on. Basically, what I'm saying here is that there is this push to sort of try and get the train to jump over this gap, and we just need to throw more data and more power at it. And the reality is that's just not sustainable, and there are other ways of doing this. Let's talk about those other ways now. So, personally, I'm a big proponent for taking a human-led, a human-centric approach here with the use of a variety of tools. I think there's a danger in the tech space that we get very hung up with the particular new technology. Things get very hyped and we just kind of get somewhat blinded into just using those technologies. I think the beauty here of human ingenuity is we can use a variety of different tools to achieve an outcome. So on this picture now we have some climbers using a variety of different tools to scale the cliff. So the climb isn't a straight line. We use a range of tools depending on what's appropriate for the situation. And so that human-led approach is what allows us really to combine efficiency with oversight to get the benefits of AI and preserve trust because there's still a human very much driving this. And we can measure energy and carbon performance alongside the kind of effectiveness of the tools, and we can keep things far more sort of centered and grounded by having far more thoughtful approaches to how we build some of this technology. And this is a case of kind of choosing the right model for the job, and not just choosing the biggest, most expensive, most brute force model. It's choosing from a range of different AI models and also complementary technologies. It's not always about AI. Sometimes it's actually about improving the data quality or other techniques to work with the AI. And I think sometimes the AI shouldn't be at the center of what we're trying to build. The person, the human team should be supported with AI and other tools, other technologies where those make most sense. So I make an argument that we really need policy to support this human-centered AI approach to ensure that AI innovation is resilient, scalable, and that there's a sustainable climb to value and not a reckless leap that pollutes the environment and potentially crashes our markets. What might this look like? So what I wanted to do now was use another analogy, and I wanted to just spend a little bit of time looking at time. So when time was introduced into society, clock towers were often the main way people told the time. And there's some parallels here that I want to draw with AI in a moment. But of course, with time, it didn't just stay as a clock tower. It became a mantelpiece clock. It then became a pocket watch. We now have wristwatches and smartwatches and so on and so forth. So, things don't stay, innovations don't stay in the shape and the form, that they're first introduced. Things evolve. And I think the same is certainly true of AI. And we're seeing that AI is moving from the centralized approach to more edge AI type approaches. And for those of you listening who are technologists and have seen the technology world evolve, there's similar parallels in the tech space. We've had mainframe technology, desktop PCs, and now smartphones. And I think what we're going to see over the next few years is that centralized AI has some advantages, but it's not the only way to run and create the platform for AI. Yes, centralized AI has a lot of advantages for model training, but you need to think about the lack of transparency and also think about who benefits from centralized AI. When it comes to more sensitive use cases or data, often what's more appropriate is more controlled private infrastructure, perhaps private cloud or co-located infrastructure where there's more control over where that infrastructure is running. The other benefit this has is there are really interesting innovations already happening in the UK to take some of the heat that's generated by AI infrastructure, because AI infrastructure currently runs very hot. As I said earlier, it's in a lot of cases it's brute force, so it's generating a lot of heat because we're throwing a lot of compute power at the problem. We can use that heat for other things, like we're seeing data centers sited next to swimming pools that are being used. The heat from the data center is being used to heat up the swimming pool. We're seeing really interesting innovations by putting compute on the sides of people's hot water boilers to power an awful lot of their hot water needs. So there are ways to kind of get more creative about this problem. That actually do we really need lots of centralized infrastructure, or can we diffuse and disperse that infrastructure out? And the diffuse sort of approach is interesting because from an energy demand perspective, it's far easier to decarbonize if we can actually push out that energy demand to places where there are renewables. One of the challenges we have at the moment is grid connectivity is providing a bottleneck for the AI rollout, because there simply isn't enough centralized sort of power, grid infrastructure and distribution capacity to get the power to where we need it when it comes to big data centers. If we flip this on its head and we think about running AI on device, that potentially allows us to disperse that consumption out to the consumer or to the individual businesses that are consuming it, and so that has advantages for the decarbonisation and adoption of renewables. What I should say here is this isn't just about where you're accessing AI from; it's fundamentally where the AI is running, and so we're seeing lots of signs already that AI is ultimately going to end up on people's phones. There's a number of reasons why that makes sense. There's privacy, there's the fact that this is just then an additional app. It's a marginal cost on top of existing infrastructure. And from a sustainability standpoint, I talked earlier about the fact that our hardware, our devices are a significant part of the footprint. well, wouldn't it be good if we could sweat that asset more and actually get it to do more? In a lot of cases, our devices really aren't being utilized at the level they could be. And we could be using our devices overnight and various other things. There are plenty of opportunities to get more value out of our devices that we've already consumed and will continue to buy over the coming years. So there's some interesting things here. What's allowing that to happen is really open source models. So you may have heard of some of the open source models that are out there. There's a French model called Mistral. There's others from the other technology companies as well. And the advantage of these is because they're open and available, you can download them and run them on your own devices. So I think we're starting to see more and more of that happen, and that's what's enabling this diffusion or this edge AI sort of trend that we're starting to see. And I think we'll see more and more of that. So in terms of the opportunities for the UK specifically, I said I was going to talk about. I think ultimately the UK has an amazing position as scientific and academic powerhouse with some amazing applied AI expertise as well, with the likes of DeepMind and others. And so we have an opportunity here to capitalize on that. But I think before I get onto that, really we need to think about how we measure and ensure that we're not being blindsided, that this is a multi-dimensional story, not just a one-dimensional story. We need to think about the measurement of the hardware, of the electricity consumption, of the water consumption, and so on. We need those metrics. So we need those measurements to be embedded in our procurement and the way we do governance of technology. We need to right size our use of models, and I think in a lot of cases, actually domain specific models. So models that have been designed to handle a particular problem or a particular challenge are going to be far more effective than these general purpose ones that are often massive and just a sledgehammer to crack a nut. We need more nutcrackers, not just sledgehammers. And as I said just now, we need to use a range of hardware, including our local end user devices. The edge AI potential needs to be really thought about rather than just assuming all of this needs to run in big centralized data centers. So in terms of the UK, I think we've shown that we have this amazing powerhouse, as I say, of innovation, and I think our combination of highly high-end engineering, our regulatory framework, and I think there's some really interesting sort of avenues here where we can look at the constraints that our power grid and our natural constraints as a smaller country within Europe allow us to think about the efficiency improvements. If you think about the enthusiast when it came to things like Linux, the open source movement, software movement with Linux, people were building that themselves. And I think there's an opportunity here to kind of allow enthusiasts and academics and scientists to build their own models on their own infrastructure. And naturally, that will drive them to create more efficient, more effective approaches to AI. So the bottom line here is this isn't just about building and using the biggest AI systems. It's about using AI smartly, efficiently, and responsibly to deliver better outcomes for less. As I said, otherwise, there is a danger that the required investment doesn't achieve the returns, it doesn't wash its face. And so hopefully you found that interesting. If you'd like to find out more about our work on sustainable technology or AI, please do feel free to connect with me on LinkedIn or visit our website at scottlogic.com. Thank you.